Hello and welcome to the introduction to the Laser-Tec light and optics experiments. My name is Mo Hasanovic and I'm here for the Laser-Tec, the Center for Laser and Fiber Optics Education, which is the National Science Foundation supported advanced technological center that comprises of community and state colleges, universities, high schools and technical centers, trade associations and laser and fiber optics companies. I also serve as a professor of electronics engineering technology at Indian River State College in Florida, teaching multiple courses in the field of photonics. With this short introductory video, I would like to introduce to you our light and optics experiments kit. We live in the 21st century, a century that has been by many scientists labeled as the century of photonics. This is a relatively new field, and if you are not familiar with the term, it represents a broad scientific area that covers all technologies and applications of light, be it generation of light, such as in the case of laser technologies, manipulation of light, for example, to create a quantum computer, transporting particles of light that carry useful information in telecommunications, light detection to analyze material properties in chemistry and biology, and finally using light energy with numerous commercial applications. This is an exciting and developing field. We are already harvesting the benefits of many technological advances that have been made over the last few decades, such as, for example, use of lasers, fiber optic cables, touch screens, to just name a few. But we are not there yet, and there's a lot to come. Self-driving cars based on LiDAR technology, quantum computers, silicon photonics, and many more. The future of photonics is very bright. The combination of electronics and photonics enables creation of inventions that were impossible to even imagine in the past. And these were not the inventions to stay stored on the shelves. The continuous reduction in the cost of manufacturing enables their commercialization that allows an average person to own these new products and increase our standard of living. It creates numerous career opportunities with high-paying jobs for everyone's preference, from supporting a governmental research scientific lab to getting a well-paid dynamic outdoor job with a lot of travel. With this light and optics experiment kit, we at Laser-Tec Center would like to promote this exciting and new technology and bring it closer to you. This kit offers the flexibility to improve your qualifications in this field from the comfort of your home. You don't need a sophisticated photonics lab to take first steps in this field. Through this light and optics experiment bundle that includes this kit, the book, the experiment manual, and lab videos, you are offered a comprehensive introduction to photonics that includes the theory as well as hands-on activities to help you improve your knowledge and skills. It's directed toward the average person of any age and career level. It does not require complex mathematical skills. All you need is a passion for technology and willingness to learn. Through the simple step-by-step procedures presented in the experiments manual and the accompanying videos, this technology is introduced pedagogically from simpler, easy to understand concepts to more complex phenomena. We hope that you will enjoy this material and that you will join our growing photonics community and benefit from numerous opportunities that it has to offer to make your life and career better and more rewarding. We also invite you to visit our website, where you will find a wealth of career resources that may help you prepare for job search and interviews. A list of photonics companies with potential employment opportunities is also given for you to explore. And we will also like to receive your feedback as you use this material. So please send us an email, give us a call, or leave a feedback on our webpage. With this being said, I welcome you to the light and optics experiments, and let's spend a few minutes to introduce the kit and see what's inside. Okay, so let's open our light and optics experiments kit and see what's inside. Once you open the kit, you're gonna find a nice message from our Laser-Tec Executive Director. And then you're also going to find an experiment manual. It's titled Light and Optics Experiments Book, where you're gonna find all the experiments explained, full step-by-step procedure on how to complete each lab. This kit is put together to be comprehensive, to include everything you need for the labs, including the measuring tools. So you're going to find a pencil to make notes, and then also a protractor to measure the angles. We also have a millimeter paper here and finally a measuring tape. And then also you have a tape that you're going to be using to tape certain components to your desk during the experiments. So all this intended to be used to measure, take notes, and cover that aspect of the labs. To perform the experiments in photonics, you're also going to need light sources. So the light source is going to be used to generate the light that is going to be used in the experiments. So we have two different types of light sources here. We are going to start with the LED flashlights. You have 3 of them here. They're fixture maybe of different colors, but they pretty much work in the same way. So there's 3 of them. They're powered by AAA batteries. You're gonna be given a few packages of AAA batteries that you need to install in these LED flashlights. A specific lab where these LED flashlights are used for the first time is gonna cover how to open this fixture and install the 3 AAA batteries that are being used in these LED flashlights. And then in addition to the 3 LED flashlights, you're also given 2 red laser diode modules that are here. So these 2 laser diode moduli will be used to produce a laser light that's going to be used in many experiments as a part of this series. So these 2 red laser diodes are being powered using the power grid, using the AC. You have here the adapter that is going to convert AC into 3 volts DC that's going to be used to power these laser diodes. So it's simple cable jack that you plug into the laser diode module, and then here you have the adapter that's to be plugged into the power grid. There's also a few optical components that you're going to use to produce different types of phenomena used to manipulate the light. So we are going to start with the mirrors. So you're given 2 mirrors here that are installed on these 2 wooden blocks. And then you also given an optical block here. It's currently protected by this protective sheet of paper that you can remove. And then you're also given a small prism, also being wrapped right now in the paper. And finally, you also have a small rod that's going to be used as an imitation of a fiber optic cable. There's also 3 lenses. The converging lens, diverging lens, and finally a Fresnel lens that will be used in 3 or 4 labs as a part of this series. In the small plastic box, you are going to find a few important small components that will be used both for the geometrical and physical optics. We are going to start with the diffraction grating that will be used in 2 or 3 labs. And then we also have here a thin metal wire whose thickness we are going to measure. This is a gauge 30 wire. We have a few filters, as you can see here. And then finally 2 small cards, one with a small pinhole and then another one with a vertical slit that's going to be used for our diffraction experiments. There are a few important aspects that would greatly impact the success in the experiments that you're performing, not only with this kit, but also with any other photonics experiment. One is the optical alignment, and another one is optical cleaning. So let's briefly cover both. Optical alignment means how your components are positioned, and for that we are using a few different types of holders here. So we have a laser holder, which is this big wooden block. We also have this holder here that's going to be used for LED flashlight. So you simply are going to be placing the flashlight into this LED flashlight holder. And as already mentioned, these red laser diode moduli are to be put into the V groove of this laser holder to be properly positioned. We also have 2 lens holders, 2 plastic lens holders into which you're going to plug in either a lens or filter or diffraction grating for a proper positioning. The second aspect that's going to greatly determine the success of your photonics experiments is cleaning of optical components. Optical components such as the lenses or optical blocks, mirrors, prisms are made out of transparent material and they are to be kept clean. So it's very important when you are using these optical components to hold them for their edges. You don't want to touch them with your fingers directly onto these transparent optical surfaces, because your fingers may bring certain dirt on these surfaces that are going to affect the way how the light is interacting with these optical components. So that's number one. It's important to hold these components for their edges. And then if your optical components are dirty, there are certain cleaning procedures that need to be performed. So we are giving you here an affordable way of cleaning. So there's a few finger cuts here that you're gonna place on your fingers as shown on the video. And then also a small piece of cloth that you can use to clean the surface of each of these different components. So that's an affordable way. So optical components that are part of this kit are affordable, so they don't require some sophisticated cleaning procedures. However, if you are working in the photonics lab and dealing with a high-grade optical components, then you would have to use more sophisticated cleaning procedures that are actually explained in one of the lab in this series. And then finally, the last and the most important part of your kit is related to the laser safety. A red laser diode module that you're going to be using in these labs poses hazard to your eye, and it's important to implement proper laser safety procedures. So you are giving these laser safety goggles that are going to protect your eyes from any kind of potential injury. So it's important when you're doing the experiments, especially when you are moving in front of the laser beam, to wear these laser safety goggles in order to avoid any kind of laser eye injury. This laser safety aspect is covered more in detail in the first lab of this series of light and optics experiments. Here we are going to conclude our short introduction into the parts of our light and optics experiments kit and move on to the series of light and optics experiments. So I wish you good luck. I hope that you're going to enjoy our light and optics experiments, and most importantly that you're going to learn and increase your knowledge and skills in this important area of science.